Hello, good day. My name is Geol201 INC and I will be presenting an article review by Carla B. Dimalanta of New Features from Romblon Island, Key to Understanding Arc-Continent Collision in Central Philippines. There are complete aphyolite sequence and melange found for the first time in Romblon Island group, which is located at the central part of the Philippine archipelago. The island was formed on an amalgamated crust and mantle rock that are typically fault-bounded and stratigraphically disrupted. So this is the Romblon Island. Romblon is stratigraphically situated at the center of the Philippine archipelago. Geographically, part of Visayas, and it is composed of three major islands, namely the Tablas, Sibuyan, and Romblon. So in this article, the geological data and geochemical evidences have been presented to understand the arc-continent collision processes with the help of some critical information regarding the arc-continent collision, which is one of the significant events in the evolution of the Philippine island arc system. In the Philippines, the collision zone between the Palawan microcontinental block and the Philippine Mobile Belt has not yet been extensively investigated using geophysical methods. Some paleomagnetic sampling was carried out revealing the counterclockwise rotation, which is the Mindoro and the Marinduque, and clockwise rotation, which is Panay, of some islands in the Philippines. This rotation among these islands is attributed to the collision between the continental-driven Palawan microcontinental block and the arc-related Philippine Mobile Belt. The objectives of this article are to present new gravity and magnetic data from the Romblon Island group and how they correlate with the distribution of lithologic units and structure in the area. Also, to help further elucidate our knowledge on the arc-continental collision. Next slide. In this figure, it shows the interaction of the Sundaland-Eurasian, Indo-Australian, and the Philippine sea plates. This interaction had left a permanent mark in the geologic evolution of the Philippine island arc system. So as we can see, there is a rifting and opening of the South China Sea, which could have opened during the late Eocene, caused a continental fragment to break off from the southern margin of the mainland Asia. This southward moving continental fragment and the Palawan microcontinental fragment collided during the early Miocene together with the northwestward moving Philippine Mobile Belt, which is made up of arc rocks, and some parts of this are derived from the Indo-Australian margins. Clues and evidences regarding the collision are provided by the aphyolite and aphyolitic complexes which have been mapped in the central Philippine region such as Mindoro and Panay. Also, aside from the aphyolite complexes, the extent of the collision zone had also previously been delineated on the basis of the correlatable metamorphic suits found in Mindoro and Panay. For the methodology, these were the instruments that the researchers used in order to get clues and evidences. Measurements of variations in the strength of geomagnetic field, which they use Centrix NV Magproton Precision Magnetometer and KT9 Capameter, 2000 International Geomagnetic Reference Field, and Kringing. Also, gravity survey, which is the Centrix CG5 autograv gravimeter. Now let's go to the magnetic and gravity response of lithologic units and structure. So this figure shows a north-south transect across Tablas Island, and it's shown to illustrate the different magnetic and gravity signature over the igneous and sedimentary units. So as you can see here, it has a high magnetic about approximately 215 to 2300 nanotesla, and the gravity about approximately 140 milli Galileo anomalies. It is observed over the Gabbro unit of the Sibuyan aphyolite complex. And a sudden drop in the magnetic anomalies is observed over the sedimentary units, where values are approximately 5 to 220 nanotesla. And in terms of gravity anomalies, it displays from 125 to 130 milligalileo. That's for the north. Now let's go to the west-east. Now let's go to the west-east gravity and magnetic profiles. This figure is the west-east gravity and magnetic profiles, which was compared with the geologic cross-section in Magdiwang, Sibuyan Island. In this area, peridotites and gabbro, particularly the northeast, southwest trending packets, displays high magnetic anomalies. Actually, both of these rocks exhibits the highest resistivity values during field and laboratory measurements. Also, this figure shows that gabbro and ultramafic rocks in Sibuyan Island are distinguished from other rocks unit by high gravity anomalies between 20 to 40 milligalileo. So let's go now to the data. In this slide, figure A is the geologic map of Romblon Island Group, showing that the units comprising a complete aphyolite suite are best exposed in Tablas and Sibuyan. The schist varieties are widely distributed into 3 islands, whereas marble is only found in Romblon. Inset shows a melange unit mapped in Agnoknok, Sibuyan Island. Bottom figure is a west-east cross-section along the northern portion of Sibuyan Island, which shows that the unit of aphyolite are emplaced as tectonic slices East Virgin thrust faults. Figure B map shows a location of outcrops. Geologic framework. This figure is a geologic map of Romblon Island Group. A geological and geophysical investigation was conducted in the islands of Tablas and Romblon and Sibuyan in central Philippines, which leads them to characterize several lithologic units. Most importantly, researchers discovered those critical in delineation of the arc-continent collision between the Palawan microcontinental block and the Philippine mobile belt. And these are the discoveries of the researchers in both Tablas and Sibuyan Island. So as you can see in the table, both Tablas and Sibuyan Island, they found schist varieties and diorite intrusions, where it intruded volcanic rocks and peridotites of the aphyolite sequence. Also, minor exposure of gabbros and peridotites have also been noted in the northern and southern Tablas, where the gabbros are thrust on the top of the metamorphic rocks. In your Sibuyan Island, Harzburgites, dunites, layered clinopyroxenites, layered and isotropic gabbros, diabase dike swarms, and basaltic pillow lavas and flow deposits, which make up the Sibuyan aphyolite complex. Also, these units are emplaced as tectonic slices bounded by northeast trending thrust faults. And in your tablas, lastly, in your tablas island, researchers also found older lithologic units which are covered by sedimentary sequences. The sequence consists of clastic and carbonate and also shallow to deep marine sequence, which only observed or found in Tablas Island only. Under geologic framework of Romblon Island Group, these are some of the data and evidences that help the researchers correlate the distribution of lithologic units and structure in the area. We have Sibuyan Aphyolite Complex, Agnoknok Melange, Romblon Metamorphics, sedimentary sequences, intrusive and volcanic rocks, and alluvial deposits. Next slide. For this, figure A, this figure shows a layered ultramafic from Calaton Hill Tablas. This is made up of pyroxenite, websterite, and willrite. Also, we can see some hornblendite veins measuring 2 to 3 centimeters in thickness dissect or along the layered pyroxenite exposed in the beach area. The layered unit occurs on the top of the massive gabbro along the northwest trending southwest deeping thrust faults. So, in figure B, a massive and layered gabbros comprise the lower crustal section of the aphyolite sequence. For figure C, volcanic rocks outcropping as pillowed lavas and sporadic to swarms of dikes and sills, which are found on Sibuyan. And lastly, the figure D, these are diabase dikes, usually intrude gabbros comprise as observed along the coast of Calatrava Tablas. And these dikes display medium-grained textures and have widths reaching few meters. And baking and chilling are also common along dike margins, and these contacts were used to distinguish them from volcanic flow. For the conclusion, geological and geophysical clues to the collision. As part of the clues and result to the collision, those metamorphic rocks found or which was exposed in Romblon Island Group are also believed to be useful in the delineation of the extent of the collision zone. The presence of the metamorphic rocks and the aphyolite complex strengthens the argument that the Romblon Island Group lies within the collision zone between the Palawan microcontinental block and the Philippine Mobile Belt. This geological and geophysical data, which presented and well studied, summarizes or shows the correlation of the lithologies and structures with the process gravity and magnetic anomalies. This set of information is critical to further understanding this arc microcontinental collision. And with the features that were observed in Romblon Island Group, the easternmost boundary of this arc microcontinent collision zone is believed to be located east of the Sibuyan Island. And that would be all. Thank you.